Have you ever wondered how mighty mountains slowly crumble into smaller pieces, or how jagged cliffs eventually become smooth? The Earth's surface is constantly being reshaped by powerful yet often unseen forces, and one of the most intriguing is a simple process involving water and temperature. Freeze-thaw action, also known as frost wedging, is a fundamental physical weathering process where water repeatedly freezes and thaws in cracks and crevices within rocks. This cyclical action exerts immense pressure, gradually prying rocks apart and breaking them down into smaller fragments. The core mechanism behind this remarkable process lies in a unique property of water. Unlike most substances, water expands by about 9% when it freezes and turns into ice. When water seeps into tiny cracks in a rock, and the temperature drops below the freezing point of 0 degrees Celsius, this expanding ice acts like a powerful wedge, pushing against the rock walls. Each time the water freezes, the crack widens a little more, and when it thaws, more water can enter the enlarged space, ready for the next freezing cycle. This continuous cycle of freezing and thawing is crucial, as constant pressure buildup ultimately causes the rock to fracture. Several environmental factors amplify the effectiveness of freeze-thaw action. Frequent temperature fluctuations around the freezing point, such as those common in mountainous or high-latitude regions, are ideal. The availability of water is also paramount, as dry conditions prevent the process. Furthermore, the existing structure of the rock, including its porosity and the presence of pre-existing joints or faults, makes it more susceptible to this powerful form of weathering. Rocks with many tiny pores can even experience microfractures due to ice forming within the pores themselves. You can observe the effects of freeze-thaw action in many places, even close to home. Look for potholes forming in roads after a cold winter, or notice how garden walls and pavement sometimes crack over time in colder climates. These are real-world examples of water freezing, expanding, and causing structural damage. In nature, this process is responsible for creating scree slopes at the base of mountains, shaping dramatic rock formations, and even contributing to soil formation by breaking down parent material. Understanding freeze-thaw action helps us appreciate the intricate ways our planet transforms over vast timescales. This seemingly simple interaction between water and rock is a key driver of landscape evolution, constantly sculpting Earth's surface and producing the sediments that eventually contribute to new geological formations. It is a subtle but persistent sculptor, reminding us that even the hardest materials yield to nature's patient persistence.